Okay. Okay. So sorry. Okay. So I'm gonna make another video here. I'm trying to just post a few ideas that I have, put them up on YouTube, get some feedback so I can work on them, sculpt them, whatever. Especially if you have a degree in science, physics, whatever. So I had posted one earlier, but this one's going to be a relation or connection that I see within relativity, and it really might already exist in some form, and I really probably should look into this a bit more. But I have brought it up to people, brought it up to my physics teacher and other people within my physics class, and they seem to think that it's something somewhat new. So within relativity, after it had been established that the speed of light is constant, it doesn't vary depending on your relative speed or whatever, Einstein was able to use that fact and derive, time dilation and, what is it, length contraction, all those things, derived it from that concept. And and I'm not going to go into details of all that. For the most part, you should have some sort of a fundamental understanding in relativity if you want to understand what I'm saying, or if you want to respond. But for the most part, I'm postulating that I think it is the speed limit itself. It is the fact that light goes at that constant speed that is the cause of time dilation. Because and this is an analogy. I'll try to think of a better one here as I'm talking to you. But um, you know, let's say there's a nucleus and there's electrons spinning around it, and there's 2 degrees. Some people are like, that's not really how it works, and yeah, because quantum mechanics is a little different. But 2 degree, yes, it is. It does happen like that. And either way, let's just say that it happens like this to get the point across. So now, those electrons are orbiting around the nucleus at the speed of light, and now the speed of light is the speed limit. Nothing can go faster than it according to relativity, which seems to be true. But now, so let's imagine as something, so as I'm standing here, time is happening for me because those, the movement of those particles continue to happen, and um, yeah, like, so, processes are going on with my body, etc. Now, if I'm going, let's say, almost the speed of light, like 99.9999% the speed of light. So let's say I'm, whizzing by. Now, an atom with the electron spinning, okay, like it can, if we're going this way, that means that, the electron can spin back with no problem because it wouldn't be violating the speed of light. But now, as it comes back around and tries to go forward, since we're going 99.999 at the speed of light, that means on its way back, it can't go the speed of light. It has to cut its speed down by, point. It'd be going 0.0001 the speed that it could go, because if it goes any faster, if it comes back around the speed of light as you're almost going the speed of light, then you'd be violating the law. You'd be violating this, the relativity in regards to going faster than the speed of light. So now, and that would kind of explain it, because time isn't like, it's not just like a medium. It's not something out there that's like fueling things. Like, especially with relativity, it's relative, and it's not even really there. It's like we use it as a way of measuring things. And in a sense, you can go without, there's speed traveling through space time. The faster you travel through space, the slower you travel through time. There's that. But in other ways, to kind of make this concept like sink in, like if you have, and this is just a known thing, if just to show the point, you can have 2 glasses of water, and one is like warm, like, or hot or whatever, and one is cold. And if you a drop of dye, the exact same size, into each cup, the warm one, it'll drip and go, like, start to dissolve really fast. And the cold one will go bloop and just kind of slowly start kind of like assimilating into the water. And now, no, the atoms in the hot water are moving faster, like they're more active. So and in a sense, that's kind of like time, because if they're moving faster, that's, events flowing at a faster rate. And this kind of shows itself in the fact that the dye mixes faster by nature in hotter water. So I mean, does that mean it's going through time faster? I mean, in a lot of ways, no, because relative to us, there's nothing else going on there. But I mean, but to a degree, yes, that's all that it is. It's just the flow of events and their um, relation amongst each other. And so it's not like, in a way, with relativity that you can travel through time depending on how fast you go through the speed of light. It's just that everyone else is going to be like going fast through time because their electrons are going to be spinning at the same rate. Events will happen at the pace they normally do. But since you're going almost the speed of light, the electrons and all the processes that happen within you are going to be happening slower because part of the time they're going to be going against the speed of light. Like they can't go any faster. Like it's almost, and let's say in theory, if you were going the speed of light, time would stop. Like there's photons and like photons, they're going the speed of light and they're timeless. They don't travel through time, according to the way we understand things now. So let's say in theory that mass can go the speed of light. That means that the electrons and everything would be locked. Like it could not move at all because any direction, if it just, like, let's say it'd go to the back of the field of its electron orbit or whatever, it'd just be locked in that position because any direction to move from that point would be violating the speed of light. So then, yeah, time would stop for you. In a sense, it's almost like your energy is already being used towards motion. And there is kind of like a relationship there, or an inverse relation maybe, like between time and speed. And we know this, but but to look at it in that sense is kind of new, I think. And so like in a sense, it's like your energy is going to be exerted into something if it's either motion or time. But so now then these are general abstract concepts, and they just involve thought experiments and just thinking about it. But I mean, and I don't know to what degree that this is already understood. But I know that Albert Einstein kind of worked the other way around. He took that idea and derived these other concepts. But I feel like there's a more direct relationship there between the fact that they actually, between the speed of light being the reason that time dilation happens, and et cetera, et cetera. So, and to a degree, and I don't know, I haven't really thought about this, that maybe like that's part of the reason gravity affects time. Like, like other forces like don't necessarily stop the flow of electrons and stuff like that. I mean, well, they do, but they can still happen in the same speed. But gravity is kind of like its own thing. It's a different force. So maybe to a degree, it just kind of pulls on the electrons. It kind of pulls on things, stops them from, and obviously on Earth, it doesn't make much of a difference. Barely, it's small, but like a black hole where the gravity is just so intense, like, the particles, if light can't get out, why, if we think that a photon wouldn't be able to exit out of a black hole, if you were like entering it, what makes you think that it would be able to loop, the electron would be able to loop back around, or any, metabolic processes or any atomic processes that are happening would be able to go in the opposite direction? Because that's the way, atoms are. They're kind of like just moving around in different areas, going different directions. But if they were kind of going in random directions, like they couldn't go the opposite direction of the black hole because it is too strong. Everything is going in the same direction. So time would stop, which is what the theory says. So, it holds up in this sense. But yeah, I mean, it's just a thought. I don't think there's that much you can do with it, for now, at least. But I mean, for the most part, I want feedback. If this is already understood to some degree, or maybe if it just adds a little bit to the understanding, that's cool. But either way, I'd like to hear feedback and your ideas. And if you like this video, if it made you think, go ahead and give it a like. All right, thanks.